errors in JavaScript and TypeScript kind of suck. I don't think that's that hot of a take. Generally speaking, even the most diehard TypeScript fans can admit that try-catch is far from ideal. And this method of dealing with errors in our applications is rough. It's so rough that the way that we build things like upload thing requires using an entirely different library for managing our runtime with effect.ts. And as cool as effect is, it'd be a lot cooler if the syntax of JavaScript just let us safely call something that could error. And ideally, could even give us that error as an actual value back that we can use for things, like Go. If you know me at all, you know I don't like to give Golang credit for stuff, but it's one of the few things they did right. The fact that your error comes back as a value that you check before you do things going forward is not a bad thing. And the fact that in JavaScript we have to wrap with a try, we can't bind variables how you'd expect, and it's just kind of a mess, that sucks. And that's why someone wrote a proposal for a better way to do it. We're going to take a look at this proposal, and importantly, why I don't think it can ship, but also what we can do instead. So this proposal is by a community member, Arthur. He's really chill. He works on Kita and a bunch of other cool things. And he made this official TC39 proposal for a safe assignment operator. The goal is to use this != syntax when you call an await on something async, and it gives you back a tuple with the error as well as the actual thing that it responded with. I mean, this looks really good, right? Like, as soon as this was seen, it went viral. Like, if we look at Kent's tweet here, 1.5K likes on a JavaScript syntax thing. Matt made a really important call out here that it's a stage 0 proposal. The heat death of the universe is also incoming. Like, the syntax is not confirmed. I've seen a couple people, even other YouTubers, covering it like this is guaranteed to happen. But there are things like stage 2.5 plus that might never ship. This has not been acknowledged even by the official standards committee. The likelihood this ships is effectively 0. And there's an important reason why. We'll get to that in a bit, though. I want to dig into what this is and how it works. In fact, why don't we go write this ourselves? I think that'll be a fun challenge. Initially, we're going to write this in a way that's not super type safe, but it will work. So function safe await needs to have a type. This takes in promise, which has a promise that returns t. And now we can do the try catch here. Try, we'll say const result equals await promise, return null result. And then we catch e. Now we return e null. This needs to be an async function. Cool. Async function might fail. This function const random equals math.random. If random is greater than 0.5, we throw new error value too high, else we return success. Now you have this function that is returning promise string, but it's not because it can throw, and it will throw half the time. And if we were to just await that inside of something, high chance it's going to throw. But if we use safe await now, const error result equals await or equals safe await, pass it, might fail, which we call. Now we have error and results. The types are wrong. I have to await that. Cool. Oh, it's mad about top levels. Yeah, I love JavaScript. So now we have the error, which is unknown because we don't really assign it a type. The result's also unknown. But this worked. We now have the error if this failed and the result if it didn't. We just don't have the types working. But I think it's pretty cool that JavaScript's flexible enough that if you want to write your own equivalent like this, you can't have like the syntax with the question mark here, but these are effectively doing the same thing. The safe await function is providing the same functionality that this proposal would include, and you could even write a Babel plugin or a TypeScript hack that will let you write this code, and it would compile out to be the thing that I just wrote there. But we can actually do better. We can make this properly type safe. This involves some custom return types. First, we have to give it an error type. And we also have to give it a return type. We have to be more strict than TypeScript is by default with the inference. And what we've done here, let's prettify it. Oh, I have these backwards now. If we want to keep the error first, then it would be null t or e null. So with a little bit of type hacking, specifically, we add a return type to be more strict, and we added a generic error. So theoretically, we could pass it custom error types if we wanted to. Now we have this very simple function that will give us the right types. We have error, which could be error or null, and result, which could be string or null. And if we error, we return early. Now it knows result is string. Now it is exact thing before we check that. It's going to think string or null because it doesn't know yet until we've parsed the error. But now we have the full Golang experience with a simple function. I think it's pretty cool that we can brute force generate this. But thankfully, I'm not the only one who's thought this, because there's a library called neverthrow that Matt showcased here. Here, these are generator functions, which makes it even more fun. But this could error, it could pass. And when you then call it with the safe try helper, you get the result type. And the result type is very similar to what I was showing here. Won't error, safe try, function, return okay. This one never throws, so it's smart enough to parse it because it's a generator. Again, this is the effect way. Effect is really big on generator, so it's a little more leaning that way. It seems like Matt's just circling around his effect deep dive, and it's going to happen any minute now. Yeah, you have error okay result from neverthrow. Might error, the return type on it is a result, string, or error. And you can specify, I didn't read this before, and I came up with that example. That's just the example I always use. I promise I didn't pre-read. I only had the top tweet bookmarked. Yeah. Safe try is the feature in neverthrow that's really cool. Lets you write code like you normally do, only thinking about the happy path, acting as if it won't error. But unlike your code, safe try keeps track of all the errors that might occur and lets you handle them later on. So a safe try, if you wrap something that can throw with that inside of a function, and then you consume that somewhere else and then somewhere else, it can hoist that error case all the way up using the types, which is really cool. The catch is you have to yield instead of just returning traditionally. But it's, ugh. You know, I have feelings on generators. They're making a comeback right now. Yeah. But if you use yield and safe unwrap, now you get the direct access to the type without having to check for the error, and it will hoist the error up for you, as they show here, where result of safe try knows that. And if you have multiple kinds of errors that any one of these could be yielding and could be throwing when it fails, you have the different types of errors up here. So we have the JSON parse error or the local storage error. Cool stuff. It seems like a very small subset of what you would get with something like effect, but it's really easy to consume. Looks really cool. I personally haven't tried neverthrow yet. Looks great. But if you don't want to adopt generators and all of that, something like what I wrote here with the safe await function, super easy to adopt. Cool. So we've covered what it would look like to build this and why you would want it. There is one last piece we have to cover, which is why this can never ship. David Blass is one of those few people that if we disagree, there's near 100% chance he is right and I am wrong. He deeply understands TypeScript on a level almost no one does. You might have seen my videos about his work before. He's the one who made the TypeScript benchmark, not like benchmarking the runtime, benchmarking the performance of the TypeScript server in interpreting your types. He understands the way TypeScript does inference so well that he can audit your code base and make small changes that make VS Code's like IntelliSense and language server stop crashing. He's insane. Already seeing messages. I've accidentally summoned David in my Twitter replies a few times. He was right each time. Yeah. I would not want to be on the side disagreeing with him because it means that I'm wrong. Thankfully, over time, I've slowly become more and more aligned because he's always fucking right. And here was his reply when he saw this syntax proposed. It will torpedo if they don't change the syntax soon. It's too much like question mark equals, and it breaks intuition about question mark relating to null or undefined. This is really important. This syntax lets you assign a value if it's not already assigned. So if you have something like, let's move down here, let x string if math.random is greater than 0.5, then x equals hello. But down here, we want to assign it to something else if that case didn't get hit. We could do x equals, we skipped the random, but that's always going to get hit. We could put this in a function. We could have a check to see if x already exists or not, or do that. Now it will only reassign x if it doesn't already have a truthy value. Actually, I think it has to be null or undefined for this to work. This is really nice syntax where this only gets assigned if it is null and it gets skipped otherwise. Deleting one of these question marks is just a massive confusion. And now that he has proposed it like that and mentioned that part, he's right. This Gabriel just confirmed for me, by the way, this only works if on null or undefined. If this was set to 0 or a nullish value, even empty string, this reassignment won't work unless it's set to null or undefined. Really handy syntax for turning a complex machine of assignments into a really simple way of assigning the value. Like most of y'all, and I know I'm included here, what I would have done here is if x equals undefined. X equals, it was skipped. Why is this mad about? It's used before assignment. Oh, yeah. Because I haven't assigned it. It'll even be mad about that. God, fucking JavaScript, man. We skipped the random check. Yeah. This is a really handy syntax. I should probably use it more. It makes life a lot easier in a lot of places. Nullish coalescence is great. The double question mark syntax does so many useful things. It should not be tainted. And question mark almost always means an if of some form. Single question mark is for ternaries. Double question mark is for coalescence. These things are great. But because of that, this is stepping on existing like mental model space. The types of errors are an annoying thing to deal with. The library that Matt showed off has error types built into it, but it would be a lot nicer if they were built into TypeScript itself. The fact that you can infer types for returns but not for errors is obnoxious. Like there aren't really good reasons to not have a type system on top of the errors, and it sucks. So this is a proposal. Apparently there's a different one as well underneath, but the throws keyword would be to say a function can throw a specific error type. So you can specify the errors a given function is capable of throwing. That way, when you catch, it knows which errors could exist. This one's a big old mess. Throws clause. Yeah. So the problem is if you make this function fn that takes in a number and it throws if you pass it 0, it's not clear that when you use it that it might throw an error, and it's not clear what the type of the error is going to be, even if you do know it's going to throw an error. That's both very real problems. By introducing optional checked exceptions that type systems can utilize for exception handling. Checked exceptions isn't agreed upon. For example, Anders Hellsberg disagrees with it. Handcuffs. Interesting. Do you have a whole article? The trouble with checked expressions, a conversation with Anders, part 2. Anders, this is pre-TypeScript too, talking about how like exceptions are hard to check because you don't know all the things that could cause an exception. I haven't read this. I'm not going to dig too deep into it now. If y'all are interested in a deeper dive on exceptions and errors from the guy who created both C# and TypeScript, let me know and I'll try and get to that. But here we have a function fn throws string, same thing as I was talking about before, where you can specify as a return type for the function that it can throw a thing. So here we have a function that is its return is a promise which returns string, but it also has an error that it throws. Got a lot of positivity. Just to clarify, from Daniel Rosenwasser, he's like the PM running the TypeScript team. Great dude, by the way. Daniel is in the fucking trenches making sure this stuff goes well. One of the ideas here is not to force the users to catch the exception, but rather to better infer the types of a catch clause variable. This is Ryan's reply. Ryan's one of the gods on the TypeScript team that deeply understands these things more than almost any other human. Apparently this is a long comment. It's going to be a fun one. After reviewing all the comments here over the years and much discussion internally, we don't think that the JavaScript runtime or overall ecosystem provide a platform on which to build this feature in a way that would meet user expectations. Yeah, JavaScript doesn't have errors as a first-class citizen enough to like do this in a way that makes sense. It's too likely you'll get an error that doesn't meet the shape of what you're expecting. But I want to break this one down. Per popular request to either add the feature or close the issue for clarity, we're opting for the latter. As with minification, we're implementing a 2-week cooldown period on further comments. There are a few different facets that have been implied by the proposal, and it's worth sort of breaking them apart individually. The first is the ability for a function to describe what kinds of exceptions it throws with commensurate effects on catch clause variables, like typed exceptions. And also the ability to enforce that certain exceptions are explicitly handled or declared as rethrown, aka checked exceptions. This I could see why it would be really hard to do in JavaScript. This feels easy enough to add. But this is like, I can see when I'm writing the code what types of errors you get. And here it's like you can behave differently based on those types of things. Overall observations on exceptions in JavaScript. We need to examine how exceptions are used in JS today to see how it fits in our goals of typing idiomatic JS. There are definitely some places in JS where probing the thrown exception is useful. You might have code that's likely to throw a few kinds of known exceptions. So if it's an instance of type error, we log. If it's a string, we 2 uppercase it, else we just hoist and keep throwing. Since there are usually extremely few guarantees on what kind of values E might actually have, the existing dynamic type test pattern used in TypeScript is appropriate for writing safe code. More on that later. That's fair. You basically never know what E is throwing. And if you're calling JS code, if it's calling browser code, if it's calling other things, E is as any as they come. And you're encouraged to treat it that way. Yeah. It's impossible. As Chad just said, thank you, CJE. This is technically impossible because you never actually know what JS code is going to throw. I could argue similar with you never know what it's going to return, but it's slightly more guaranteed. A proposed TT39 feature Pattern matching and catch clauses would make these sorts of checks more ergonomic while at the same time providing useful runtime guarantees. I'm curious about this. You know me and my love of pattern matching. Oh, that is nice. Multiple catches with checks. Oh, that is nice. I do like this. My functional programming brain is very happy with this. Thank you for showing me this. Case match, code, enoent. These are the different options for the syntax for it. Those are all cool things. Looking at the landscape of the JS libraries, the sort of rich inheritance hierarchies of various error and exception classes seen in languages like C# and Java are not widely adopted in the JS ecosystem. That's putting it lightly. Most of the libraries I use, I have no idea where and how they error. Apparently, Lodash is 200 pages of docs, but they don't have any description of what kinds of exceptions are thrown, even though the source code reveals that a handful of functions are absolutely capable of throwing exceptions. The one apparent user serviceable throw in jQuery is not mentioned in the docs at all. React mentions some of the exceptions it can throw, but not all of them, and only uses language like throws an error, opting not to include specific information about what type of exception. An 850-page book on Material UI never mentions exceptions and only talks about throws from user code. There are no documented exceptions in Xstate. The Svelte documentation over the course of 100 pages simply says throws an error in one occurrence. You cannot read the node documentation and accurately predict which properties will be present in a failing call, like fs.open does not exist, error, yeah. There is not good docs on all of these things. And that's actually a fair point. As I was saying, you can kind of know what a function returns. It's harder to know what error is thrown. The docs are a great place to start. And the docs do say what is returning, and they don't say what's being thrown for most of these things. That's a very fair point I hadn't thought of. See Mark in chat. This makes him feel better about the lack of docs about errors and upload thing. Yeah, we're matching the standard set by Svelte in React. But yeah, we should fix it. In reality, passing invalid inputs to most JS libraries typically leads to exceptions only tangentially related to the error being made. Like passing a primitive where an object's expected in Xstate produces uncaught type error, cannot use in operator to search for context in 32. That's hilarious. That's like if you pass a number or a string, they're not even checking that in Xstate, so it just throws this obscure error. JS programmers are generally expected to realize they made a mistake earlier in the call stack and fix their own problems, rather than to look for very specific errors like you would get in C#. This situation doesn't seem likely to change anytime soon, unless you're using effect or something like it. And if you're diving in, like effects catch is you have to use it for everything for it to work this way. So here we have like effects web server that we're using for hosting the upload thing backend in your project by creating a middleware. And when we use effect.gen, we're forcing ourselves to not just throw, but yield errors instead. And now when we consume them, if I find some code where we're handling different errors, too many use effects in here. Hey, we're using micro for a bunch. They made a special small version of effect for us, which I love. Cool. Ignore the type errors because I haven't installed anything here recently, so this is all just like out of date types. But we're calling micro, which again is just a smaller version of effect provided by the effect team. And we return micro.tryPromise, where we handle the try and we handle the catch, and we turn this error, because again, we're calling fetch. So if that errors, we don't know what it is. It's this browser standard error. It could be a shit show. So we manually change the catch to take that error, and we create a new fetch error and instantiate that how we want it to be shaped. And now we pipe it to micro.map, which is the place where we actually assign the URLs we got from there, and we trace it with our fetch tracer. But now when we call it, we know and can filter on good or bad states. So we can call micro.filter or fail. Okay, cool, pass it on. If it's not okay, then we return the bad request error. And now when we map it, we won't have the errors. This is a way to like filter out the ones that failed and still hoist those errors while passing the success values down. But this is like, we had to write our own custom fetcher. We had to write our own custom fetch error. We had to write all of these things in order to glue this together this way. And the code that we're writing barely even looks like TypeScript anymore. But this comes with a massive win that we now know where and how errors occur, and also can manage those the way we choose, because every point throughout, we can handle those errors. Has this code been hit? This code absolutely gets hit. It gets hit all the time, and it is finally the result of this code being written is we have a much better idea when a user has an error with upload thing, where it came from, because we own those error processes now. It's a really good thing for us to move to. It took a while. I still barely understand it because I haven't had time to contribute to it much yet, but the team, specifically Mark and Julius, they seem to really get it now, and the code they've been writing is awesome. So unless you're using something like that, you're probably fucked. As Ryan says here, there isn't a culture of strongly typed exceptions in JS, and trying to apply that culture after is unlikely to produce satisfactory results. Why is it absent in the first place? Now we get to blame the language. Fun. Language capabilities. This culture is a predictable consequence of the way that JS exceptions work, without a first-class filtering mechanism to provide the ability to only catch certain exceptions in the first place. It doesn't make much sense to invest in formalizing error types that can't be usefully leveraged by developers. The other reason that these aren't really used much is these sorts of exceptions are not needed in the same way they are in other languages. Interesting. Other languages have critical constraints that aren't present in JS. Pervasive, explicit, and imperative resource management, wherein every function needs critical cleanup code to ensure correct long-running operations of the program. Things like free and delete. Oh, that's a fair point. If something fails in JavaScript, you can expect the garbage collection to deal with it going forward. Where in other languages, if something fails in a certain way, you need to deal with that and clean up the result to not leak memory. The other languages also don't really let you return different types of values from a function, so they have to error in the different cases instead. And there's often lackluster support for first-class functions. JavaScript, you don't have to worry about any of that. Apparently, he breaks down all of these in detail. I feel like I understood those points already. If you want to better understand these, right now, before I forget, I'm going to go put this in the links so that this source will be in the description if you want to read this whole thing in detail. Now here we have an interesting call out of avoidable as well as unavoidable exceptions. Avoidable errors are logical errors in the calling code, like you call .find32 on an empty array. These should never occur in production code, and you can always avoid them by calling functions correctly. It's a you're holding it wrong type thing. But there's unavoidable ones, like network sockets being closed during transmissions. You can't control these things. They should be considered always possible, and programmers should always be aware that they might happen. In other words, something went wrong. So let's talk about typed exceptions. Even setting aside the lack of exception typing in the wild, typed exceptions are difficult to describe in a way that provides value in the type system. Typical use case for typed exceptions would look like this. We try some code and we catch E. It'd be nice if we knew the types of errors E could be. There's a super type of what we think some code can throw, or automatically type it based on what errors we think some code could throw. Current state of support. As a baseline, we need to look at how TypeScript handles these cases today. Consider some basic exception inspecting code. If E is an instance of type error, log. If E is a string, we write to uppercase, else we throw it. Who else here? Let's see some chatters. I know I'm not the only one who's written basically that exact code before. I want some ones in chat if you've written the 3 checks on error. See if it has a message. If it doesn't, check if it's a string. And if not, you just say fuck it. Because I know I'm not the only one who has done exactly that and just said fuck it. Yeah, look at all those ones. A lot of us have done exactly this. This code already works. E.message is strongly typed, and property access in E is correctly refined, even if E is any. E.to uppercase is strongly typed as well. More cases can be added, like detecting E as an instance of range error. If we accept as a broadly true principle the following: most JS code doesn't have documented exception behaviors. Most JS code has at least some indirection, so it can call code with undocumented exceptions. That's an important one. Even if a given function has handled all of the errors it directly calls and it can directly cause, if it calls something that can throw as well, you have no guarantees there. So the whole hierarchy, top to bottom, has to have these types or it's useless. And then, of course, safe handling of exceptions requires taking both of these into account. I agree with all of these principles. It's funny, it's in my head when I was talking about this with Mark last night, why don't we have typed errors in TypeScript? I was thinking through these things, but wasn't smart enough to say, yeah, that's the case. In the end, I concluded, they probably should at this point. It can't be that much different than how chaotic a return is. I'm wrong. This is fucking chaos. But yeah, as Ryan says here, if all of these things are true, which we can agree they are, then the right code to write and put into your code base is the code that we had above here. Since we can't actually know which of these types there are, even if we strictly type things more often, a throw, as CJ just said, returns don't bubble, throws do though. So that thrown value from the wrong function could come all of the way up. Real problems that we need to be considerate of. And the only way to properly consider those in your code base is to do this bullshit. So we're kind of stuck with this code. Very fair points. The default throw state of unannotated functions. 100% of function declarations today don't have throws clauses. Also a fair point. If we added this throws, then we have to make a decision about what to do with functions that don't have one. If it doesn't have one, it might be that it doesn't throw an exception, or it might be that it throws any exception. If we assume that these unannotated functions don't throw, the feature doesn't work until every type definition has an accurate throw clause. Also fair, because do something one throws need exception. This one can throw awesome exception, but we didn't specify it. Now when we do this try catch, this error is incorrectly typed. If we assume all unannotated functions do throw, the feature largely doesn't work until every type definition in the program has accurate throw clauses. Do something one, throw need exception. This one doesn't throw, but we didn't annotate it. So now E has to be unknown, even though we know this doesn't throw. So we either have to annotate this throws never or something like that, or we just blindly assume. Very fair points. Assignability would also have to take into account throw info. Just throw function void equals anonymous function throw new type error, don't call me yet. Foo gets passed just throw as a callback, and we call the callback here, but we gave it a different type. Yeah, that's actually a very fair point. If we have this type for just throw, and it's throwing and it's wrong, and now we're passing this function here, does this definition here for what we're passing it also have to specify what errors can be thrown to the function you pass it? That sucks. That's a very fair point. Getters and setters can also throw. God, hadn't even thought of that. There's a lot of very good points here. Checked exceptions, the other half. A related feature request is the ability to have checked exceptions, as in Java or Swift. This feature requires that functions either catch specific exceptions or declare that they rethrow them. So if a function calls a function that can error, it either has to handle that error or it has to throw that error up or a different error. You have to do something based on the errors. Beyond Java and Swift, though, no other mainstream programming language has adopted these features. The common opinion amongst language designers, including ourselves, is that this is largely an anti-feature in most cases. If I recall, the Swift developer regrets this because of how much harder it makes like the compiler and type checking work. Checked exceptions aren't seen in any of the widely used and liked languages today, with most new languages opting towards something closer to the result type, which is a pattern in Rust, also similar to what they have in Go, or as also a similar unchecked exception model. Porting this feature to the JS ecosystem brings along a huge host of questions, namely around which errors would be subject to checking and which ones wouldn't. The ES spec itself defines over 400 places where an exception is thrown, and the spec clearly doesn't make a hard distinction between avoidable and unavoidable exceptions because it wasn't written with this concept in mind. The distinction is also fuzzy in some cases. For example, type error is thrown by JSON.stringify when encouraging a circular data structure. In some sense, this is avoidable because many calls to JSON.stringify by construction cannot produce circularities, but other calls can. It's not really clear if you should have to try catch a type error on every call here. Fair, like if you know that what you're passing to JSON.stringify is fine, you shouldn't have to catch it, but now you have to have the syntax able to specify that. And the syntax error being thrown by JSON.parse if the input is valid, it might be impossible to have it happen or it might not be. How do you specify those things? Same with regex. Do you have to force a try catch around every single regex? The only way you can make regex worse is if you add try catch to all of them. So what would change there? I love this. This is actually a really important thing I think everyone should do when they have a hard stance on something. You should be able to clearly state what it would take to convince yourself otherwise. For example, I think Flutter is a garbage pit, dumpster fire, terrible framework that no one should ever use for anything. But I can be convinced otherwise. I need to be shown a Flutter app that I would actually use every day. That's all it takes. If somebody can make me a good enough Flutter app that I actually use it and don't mind using it, I will immediately go unlist all of my videos about Flutter. I'll even make a new one apologizing. But until I have that one good Flutter app on my iPhone, I'm going to continue saying it's a garbage fire dumpster pit that nobody should fucking touch. Hopefully you can understand what I'm saying here. Every hot take you have, you should be able to clearly state what it would take to change your mind and get you to walk back on that. So until you show me that good Flutter app, I'm not changing my mind. Let's see what it would take to get the TypeScript team to reconsider typed errors. These are the 2 points that they would consider, that would make them change their mind here. Widespread adoption and documentation of strong exception hierarchies in JS libraries in the wild. So if everybody moved to effect neverthrow, they would reconsider. Or TC39 proposals to implement some sort of pattern matching criteria to catch exceptions. Arguably, this would just work by itself the same way InstanceOf works today. This is, funny enough, the syntax that started this whole video, so that could happen. So, TLDR. Any feature here implies a huge amount of new information in DTS files that isn't documented in the first place. Yep. Good exceptions introspection, like catch E if E instance of X, already works today. And anything more inferential than that is unlikely to be sound in practice. Yeah. Love that. Cool. So that's why we don't have it in TypeScript. Now we just need to find the right syntax to have it at all. Apparently, we got some new syntax proposals. Let's take a look at those. Personally, I like try in the front or the back. I'm fine with either of those. I actually do like that though. But at that point, like if you're putting a keyword in front, just put it around a function. Like, I don't like the idea of another way to define variables is my hesitation around 3. We already have var, const, and let. I'm leaning the try here. But the use of a keyword resulting in a tuple still feels a bit strange. But of these, 2 is my personal choice for sure. I hate the question mark at the end. It just it breaks the way you read through it. And the other issue I have with that and with this is they both imply that this function returns these 2 things. Because like, I'll be real, my brain skips over the variable definition. Like I just blank on the thing on the left unless it says let, and then my brain clicks in like, oh, I need to pay more attention here. But usually my brain just skips whatever's on the left there. So putting it there, my brain autocomplete's going to read it as error data equals might fail, which means I'm assuming might fail is returning this tuple, which it isn't. And then when I go back to the source code and I see it's not, I get more confused. Putting a try here helps a bit with that. But at that point, you might as well just be calling a function like the safe await that I wrote, right? This is hard. Syntax changes is tough. Like I want to do a poll in chat actually. Which syntax do you prefer? 1, 2, 3, 4. Seems like people are leaning 2. I biased y'all. My mistake. Should have done the poll first. I prefer 2 of all of these. God damn it, Gabriel. Not all of us have an upside down version of our keys on our keyboard. Gonna start adding more upside down keys? Like what about upside down slash, upside down period? Yeah. Seems like within my audience at least, most of y'all agree with 2 here. I get it. I don't love any of these, but 2 would be the better. Wouldn't we have a lot of if error throw error? Yes, and that's great because now you're being explicit about it instead of the code quietly erroring and you don't see it. That's the benefit of Go. It's tedious to have the if error is not equal nil checks constantly, but the benefit here is that your code explicitly says what it's doing. You have to do something with every error, and I like that. Oh, cool. Without my biases, they were still leaning towards try as throw. Grab the snippet if you're interested. I'm sure there's plenty of others. I'm pretty sure I had a cursor help me generate this one, if I recall. I was getting hung up on the trying to avoid a return type, but without one, no amount of as const was inferring properly down the line. So the return type there is essential. Makes it a pretty simple function that gives you these behaviors. If you like it, awesome. I liked it too. And if you don't, that's fine as well. Let me know what you guys think. And if you're just going to wait for some syntax to get added, that's cool too. I'm very curious how y'all feel about this. So as always, leave it in the comments. Until next time, peace nerds.